Hi guys. So today we are working on lesson 11.3, Angle-Angle Similarity. So the basic concept behind this is if I have similar triangles, oh Lord, if I could spell, this would be absolutely amazing. If I have similar triangles, they have the same angles as each other. It's part of what makes them similar triangles. They have the same angles. They might be larger or smaller. They can face different directions, but they all have to have exactly the same angles. So I'm going to put down can be larger, can be a different size, can be turned a different way, hey, you can even flip these things, but so long can be flipped. But so long as it has the same angles, it's a similar triangle. Now, once we have determined that we have a similar triangle, once we know that, we can start doing some interesting things with this. Because similar triangles can scale up and they can scale down. And if I know one thing about one of them, I know something about the other one of them. So a big part of this particular section is using the fact that we have similar triangles, using the things having to do with similar triangles to do some interesting things. So first off, I guess it should be well, no, they have the same angles. That's how you determine if it's a similar triangle. We'll get to it in the book. They have an entire section on that one. Then if we are looking for missing measurements. Now this one you might get a little confused about. Okay, so this is how I find a missing measurement when I am looking at my similar triangles. This is only with similar triangles that we're talking about here. So let's say that I have a triangle like this. And I am told that this point is 5. This is 5 feet away. This right here is another 5 feet away. This is 7 feet, maybe. Sure, let's have this be 7 feet. I know I'm going to end up with an absolutely number, but whatever, it's fine. And then this is X. I do not know how many feet long that is. Since I know how many feet this is, so the bottom length The bottom length is a 5. I can set up a proportion. Let me just show you this one. The bottom length is a 5 for the small one. The top, the side is a 7. This is for the small one. So this is just for the small one. So this is one triangle. This is the other triangle. Okay, so that's one triangle. That's the other triangle. This is the bottom. This is the side. Okay, so with me here, so this is one triangle, the 5 and the 7. This is the other triangle. The bottom for the other triangle, the bottom for this big triangle is actually 10 feet because it is that 5 plus that 5. So it is 10 feet. I do not know what the X is. Okay, do you see? That is the side and the bottom of one triangle is equal to the side and the bottom of the other triangle because they are similar triangles. I can do that because they are similar triangles, so their proportions are the same. It's exactly the same as when we were talking about pictures inside frames earlier, and we were saying, okay, so this picture is 2 by 2. I want to see if I can make it bigger. I want to make it 3 times bigger. And then we multiplied it. We multiplied the one side by 3, and we multiplied the other side by 3. And we ended up with a 6 by 6 instead. Remember that? We've done that before. We did that several chapters ago, actually. We can do the same thing here. Now, some of you have already figured out what the answer is. You already know what X is, because there is 2 ways to solve this. There is the way that when I give you numbers like that is super easy. And then there's the way that you can do it when you don't even know where to start. So I'm going to show you the super easy way that's driving some of the kids bonkers because I haven't done it yet. And then I'll show you what to do if you don't even know where to start. So the super easy way is to go, what did I do to that 5 to make it a 10? I multiplied by 2. Whatever I do to the bottom, whatever I do to the bottom, I have to do to the top. So if I multiply that by 2, I multiply this by 2. 7 times 2 is 14. So X is equal to 14. So let me pause for a second and take care of my battery. Okay, so if the numbers aren't as easy as that, if you're looking at it and you're going, I have absolutely no idea what to do with it, this is what you do with it. I'm going to come down here because I have some more space and I need a little more space. So I have my 7/5 is equal to X over 10. We can do, what were we calling it? The butterfly, or we can do cross multiplication. So we can do that. And we end up with 7 times 10 is equal to 5 times X. Remember that? 7 times 10 is 70. 5X. Since the 5 is bothering the X, we are going to, it is connected by multiplication, so we are going to divide to get rid of it. The 5's cancel out. 70 divided by 5. If you go into your calculator, you will find that it is All right. Yeah, because it absolutely should have worked. It should come out to be 14. Yep, 14. All right. So this, you can do this if you look at it and you go, oh, it's obvious what they did. I know exactly what they did. I can just do that. If it's not obvious what they did, you can go ahead and do it this way. All right. So here's what we're going to do. I'm now inside your book. I'm on page 363. We are not drawing the triangles for a couple of reasons. I don't think you have a protractor at home. I mean, you can go ahead and draw it if you want to, but you also don't have anybody to compare your drawings with. So, since the entire purpose of it was to prove to you that triangles that start with the same angles can look different. They can be a different size. They can be turned in a different way, but they are still similar to each other. I'm going to skip down to number 1 under reflect. Number 1 says, if two angles in one triangle are congruent, are congruent to two angles in another triangle, what do you know about the third pair of angles? Well, let's talk about this for a second. How many angles are in a triangle? 3. Do you remember what the number of degrees is that the 3 angles in the triangle are equal to? 180. So if I take the same 2 numbers and subtract them from 180, am I always going to come up with the same answer? That's what they're asking us here. So it's, what do you know about the third pair of angles? They will also be the same. There's no way, literally no way they could be anything other than exactly the same. Number 2, make a conjecture. Are 2 pairs of congruent angles enough information to conclude that 2 triangles are similar? I would say yes, because the third angle will always be the same. Yes, because the third angle will always be the same. It's not going to just change. It's always going to be exactly the same. Next page. They're showing, using the fact that we know that all 3 angles are equal to 180 degrees to determine whether or not the 2 triangles are similar to each other. So let's go down to the bottom and triangle NOP and triangle QRS and compare them to each other and see if they're similar. So what we need to do is we need to determine what the last value is. So for number 3, I already know all it together is going to be 180 degrees. I'm going to subtract out the 58, and I'm going to subtract out the 70, and I'm going to see what's left over. I could have set the problem up the way that they did. The way they set it up would have been 58 plus 70 plus x is equal to 180. Algebraically, we would end up subtracting the 58, subtracting the 70, and then getting our answer for x. Do you see how I did that? You see where I'm going with there? So instead of forcing us to go through the entire algebraic process, I just said, okay, fine, let's subtract the other two and find out what we're left with. Does that make sense? Still with me? Okay. So let's go ahead and do that. 180 minus 58 minus 70 equals 52. So its third degree is 52. I do not know why this keeps going out of focus. Its third degree is 52. I don't see a 52 in QRS. So no, they're not similar to each other. They share one angle, they do not share all three angles, and they have to share all three angles. So no, they do not share all three angles. They don't share all three angles. So next page, 365, find the missing measures in similar triangles. Well, this is exactly what I was talking about how to do on the other one, where you're trying to figure out how tall a kid who's playing tennis is based upon a angle that you're looking at from the ground going up, and then we know how tall the item is that's in between the ground and the child. We do not know how tall the child is, but we know the distances of everything. And so we end up setting up the proportions to each other, and the way they do it is simply by multiplying the 0.9 by both sides instead of doing the entire cross multiplication. So you can do it that way too. You can say, what's bugging the x? 0.9 is bugging the x. How is it bugging the x? Well, it's division. Okay, so let's multiply and get rid of it. And you can do it that way and then just divide out. The same thing ends up happening. Same thing every single time. Okay, so number 4. Let's check out what this is asking us. Suppose you set up a proportion so each ratio compares parts of one triangle as shown below. The height of ABC and the base of ABC, the height of ADE and the base of ADE. Okay, they're similar triangles. We're comparing height to height and base to base. And we have everything for one triangle on one side and everything for the other triangle on the other side. I don't have any problems so far. Show that this proportion leads to the same value for height as in example 2. Okay, so it wants us to show that 0.9 over 6 is equal to h over the distance between A and D, which is 18. Now, I am going to show you the book's way of doing it. They multiplied by 18 on both sides. So we're going to cross that out. 18 times 0.9, 9/10 equals 16.2 divided by 6 equals 2.7. Now, That still gave us exactly the same height. Now, the reason why they did it that way, the reason why they had us do it that particular way, is because if they did it the other way, if they did it the way that we had done it before, the butterfly method that we were talking about before, if they had done it that way, this is what would have happened. The initial problem that they set up was 18 over 6 is equal to, oh, I see. So they did base over base is equal to height over height. You can set it up that way too. I don't typically set it up that way because I find this way makes a bit more sense. So using the butterfly method, I would end up with this. I would end up with my initial problem looking like this. 18 times 0.9 is equal to 6h. Had I used the butterfly method up here in this one, I would have ended up with 0.9 times 18 is equal to 6h. We know with multiplication, we can switch it around whichever way we want. That is the same problem. Yeah. So it's one of the reasons why they weren't having us use the butterfly method. All right. Next one. Your turn, number 5. Oh, oops, it looks like I didn't notice we have an explore activity 2. All right, we'll check it out when we get there. So, your turn, number 5. Rosie is building a wheelchair ramp that is 24 feet long and 2 feet high. She needs to install a vertical support piece 8 feet from the end of the ramp. What is the length of the support piece in inches? So, I am going to do the shorter one, the height, over the base is equal to the longer one, the height, over the base. Okay? So this is the short triangle. This is the long triangle. Height over base, height over base. Stop doing that. If you look at this, some of you can tell right now what it is that we need to be doing. All right? For those of you who can't tell right now what it is that we need to be doing, we're going to go the slightly longer way. We can, yeah, let's do that. Let's do the butterfly. So I end up with 8 times 2 is equal to 24h. 8 times 2 is 16, is equal to 24h. Divided by 24 because I need to get rid of the 24 on that side. So I now have h is equal to 16 over 24. So I need to ask myself, what can I take out of 16 and 24? I can take out a 2. Remember, you can always take out 2s, 3s, and 5s. 16 divided by 2 is 8. 24 divided by 2 is 12. Divide by 2 again. 8 divided by 2 is 4. 12 divided by 2 is 6. Divide by 2 again. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I am left with 2/3. My height is 2/3. Number 6. The lower cable meets the tree at a height of 6 feet and extends out 6 feet from the base of the tree. If the triangles are similar, how tall is the tree? Okay, so the lower cable has a height of 6 feet and a base of 16 feet. Okay, so that's the lower cable. I do not know how much the upper cable is. That is the one that goes to the top of the tree. But I do know that it is 56 feet away. So I can now figure out how tall the tree is based upon that. So this is the lower cable's height and how far away it is. This is the upper cable's height and how far away it is. This one, I know you don't immediately know what to do to the 16 to make it a 56. So we're going to butterfly. 56 times 6 is equal to 16x. 56 times 6, 336, equals 16x. We are going to divide by the 16 because it's connected by multiplication, so we need to divide to get rid of it. 336 divided by 16 equals 21. So our height is 21. This is why we have calculators, guys. All right, so I'm going to pause for a second and look to see what this Explore Activity 2 is. All right, so let's try this one. Letter A says we need to draw a line that is not horizontal. So I'm going to draw a line like this. I'm going to label this line L. Okay, so that's my line. Inside the box, you need to draw a line. Now, on this line, you need to put points. I'm going to put point A, point B, point C, and point D. Okay, so I have 4 points on this line. For each of these set of 2 points, I need to draw both the rise and the run. So I need to draw a triangle, a right triangle, coming down from each of them. And the AB has a point E in it, and the CD has a point F in it. Okay, do you see how we're doing that? So we are looking at, we have our line, we drew 4 points on it. We are making each of those little 2 sets of points into a triangle. Okay, with me so far? So you should have something that looks like that. It could be facing the other direction. It's something similar to that. So for C, that's both A and B. A and B. Okay. So for C, what we need to do is this. You need to write expressions for the slope between A and B. So for C, it says line BE over, so this is line BE right here, over line AE. And then the slope between C and D is over line CF, which goes this way. So line DF. Do you see where I'm getting those from? So we are putting the rise over the run. Remember, run goes back and forth, rise goes up and down. So rise over the run, always. All right. So the E is the point at which we're at in the middle. It's where we join up. And the F is the point at where we join up with the C and the D. Letter D. Extend line AE and CF across your drawing. So I'm going to extend it. Okay, so now they are extended. And it's probably going to ask us what we notice. Yep, they're both horizontal lines, completely horizontal lines. And so they are parallel, which means that line L is a, do you remember the word for a line that intersects two parallel lines? Transversal. Is a transversal that intersects parallel lines. Letter E. Complete the following statements. Angle BAE. Yeah, so that's BAE. That's this angle right here. And angle DCF. Do you see what I'm doing? BAE, DCF. They're parallel to each other, so they're the same. And angle DCF are corresponding angles and are equal or equivalent, or however you want to put it. Angle BEA, so that's BEA, and angle DFC. Do you see where I'm getting that from? It's the same angle. See that? Okay, and angle DFC are right angles and are equal. They're also equal. Letter F. By angle-angle similarity, triangle ABE, that's this one, ABE, and triangle CDF, that's that one, are similar triangles. Are you with me so far? So we just, in geometry, we literally put in front of it what it is. That is an angle. This is a triangle. We literally put that there for the, so that we know what we're doing. Okay, I'm going to move this up and fold that in half. Okay, so that we can still look at this even though we're working on the next page. Okay. Come on, you can do it. Okay, so let's go to G. says, use the fact that the lengths of corresponding sides of similar triangles are proportional to complete the following ratios. BE over DF is equal to something over CF. Well, there's DF, there's CF. So what's the one that goes with DF? Oh, sorry. What's the one that goes with CF? AE goes with CF. BE goes with DF. Oh, wait. No, I'm looking at the wrong one. Sorry, guys. Okay, so that one's not the one that it is. I have these two going together. I have the DF and the BE going together. Sorry. So CF goes with AE. I got myself confused about which one they were using. Sorry. So the E's are on the top and the F's are on the bottom this time. I was putting the F's over the F's and the E's over the E's, which works just fine too. It's just not the way they had it set up on this one. H, recall you can also write the proportion so the ratios compare parts of the same triangle. So we're putting AE on the bottom and DF on the top. And so this time we're doing DF goes with BE and AE goes with CF. Okay, so this time we're doing it that way with the E's on one side and the F's on the other side. I just got myself a little backwards while I was doing it. Letter I, the proportion you wrote in step H shows the ratios you wrote in step C are equal, and so the slope of the L is constant. All right, so I don't, okay, fine. Number 7, supposing you wanted to label 2 other points on this slope as G and H. Would those 2 points have a different slope? No. If they are on the same line, they will have the same slope. They're on the same line, they will have the same slope. All right, let me move that up. And you can pause that if you want to, if you need to. I am going on to the guided practice. Number 1, explain whether the triangles are similar. Label the angle measures in the figure. So triangle ABC has angle measures of, so the first thing that we need to do is this. Number 1, we need to figure out what all the angle measures are. So I'm going to do 180 minus 41 minus 30, which will give me my final angle measure. 180 minus 41 minus 30, which gives me 109 as my final angle measure. So the angle measures for ABC, triangle ABC, are angle 41, angle 30, angle 109. And for DEF, it's 180 minus 109 minus 30. 180 minus 109 minus 30 gives us 41. So for angle DEF, we have angles 109, angle 30, angle 41. Because, then I'm on the next part, because the angles in one triangle are congruent to the angles in another triangle, the triangles are similar. So that's all the spaces going straight down. Number 2, a flagpole casts a shadow 23.5 feet long. At the same time of day, Mrs. Gilbert, who is 5.5 feet tall, casts a shadow that is 7.5 feet long. How tall in feet is the flagpole? Round your answer to the nearest tenth. So, number 2. I have 5.5 over something is equal to h over something. It is giving us the heights of each of them are being equal to each other. And so we are going to take the lengths, the distances it is away. And that is what we are going to put on the bottom. So the thing that is 5.5, Mrs. Gilbert, she is 7.5 feet away. The thing that we do not know how tall it is, the flagpole, is 16 plus 7.5 feet away because it is the entire distance away. So it is 23.5 feet away. I am going to use cross multiplication. And so I have 5.5 times 23.5 is equal to 7.5h. 5.5 times 23.5 is 129.25 is equal to 7.5h. Because that is connected by multiplication, I am going to divide it. So divided by 7.5 gives me 17.23. Repeating, it wants us to round it to the nearest tenth. So I am going to put that h is 17.2 feet for that one. If you need to pause, go ahead and pause. I am putting it on to the next problem. Number 3, 2 transversals intersect 2 parallel lines as shown. Explain whether triangle ABC and triangle DEC are similar to each other. Okay, so ABC and DEC, are they similar? Wow. Okay. Sure. Let's try this. So I have 2 parallel lines, and I have 2 lines which cross each other, like a bit like that. So I have C, E. I think you can already see what could possibly end up happening here. Because when you look at it in the drawing that they have inside the book, it looks pretty obvious that they should be, that they could even be the exact same triangle. But we need to determine whether or not they could be similar from this, and whether or not that's just making it a slightly larger triangle on the top and a slightly smaller triangle on the bottom. So let's talk about our transversals. I know that B is equal to E, that B and E are equal to each other. B equals E. I know that because this is B, this is B, this is B, this is B. Remember how we could do that before? So I know that B is equal to E. I know that A would end up here and here and here and here. So D is equal to A. They're exactly the same. So the question is about the interior ones. Let me call this one over here X. Let's call that X. So if that's X, then that's X, which means this is X and this is X. Okay? I'm writing it in pen because I can write a lot smaller letters in pen. I'm sorry if it's not showing up very well for you. If I write this is a Y, then this is a Y. If this is a Y, then this is a Y. So far, I have two angles which are the same. If those two angles are the same, see the two angles? I have X and Y here, and I have X and Y here. I have two angles that are the same in each of the triangles. If I have two angles that are the same in each of the triangles, then that means that those triangles are equal to each other. Whatever angle that is that's going on there with the C that I don't know about, I don't have any rules for it, it has to be the same angle on both sides. So what we know is that angle BAC and EDC are congruent. Let's use our vocabulary words. They're the same. They're equal. They're congruent. Since they are... Okay, now we just did this one. Since they are... Oh, bother. What was the purpose of... Since they are interior angles, since they are... No, since they are... No, not remote interior. We had a word for that, which we were using. What were we using? Alternate interior angles. Okay. Since they are alternate interior angles. That was the word that we were using. That was how we were saying that. And so then angle ABC, and angle DEC are also the same. They're also congruent because they are also alternate interior angles. So I'm not going to write it down a second time. You can just write it down both times. Same thing for both times. By angle-angle, is that how we call it? Yeah, by angle-angle, triangle ABC and triangle DEC are similar. Okay, so this is all number 3 in the colors there. Number 4. How can you determine when two triangles are similar? They have the same angles. And that's all you need to know. to determine whether or not the triangles you have are similar. So, have a good day. I will talk to you guys later. Bye.